All right, so let's look at the pH and the proximal convoluted tubule, because we know that at the corpuscle, we've gone through filtration and all the stuff was pulled out of the blood and is ended up in the filtrate in Bowman's capsule. So it enters into the proximal convoluted tubule. So here's my cell from the tubule itself, and here's the lumen. So here's the luminal surface there. This is filtrate. It's going to be in right up in here in the lumen. And in the filtrate, we're going to see, of course, sodium. We're going to see hydrogens. And on this, let's see, we're also going to see, let me put this too, sorry, bicarbonate. Because remember, we're gonna end up reabsorbing a lot of this stuff. So we're gonna end up reabsorbing, like, I don't know how many, like a gallon or something of bicarbonate, you know, back into the blood. We're gonna be reabsorbing sodium. We're gonna be reabsorbing all that stuff. So basically, to do this, the way this occurs is we have a little it's kind of like a receptor thing in the luminal membrane here. And what happens is when hydrogen comes in here and bicarbonate comes in here, this little receptor has a very important enzyme called carbonic anhydrase. So we've seen this before about a million zillion times. And carbonic anhydrase, what it does is it brings the hydrogen and the bicarbonate together and will create, remember, carbonic acid. And then from that you get CO2 plus water. All right, so the CO2, the water, of course, comes in, we know that, and the CO2 comes in. And we have carbonic anhydrase in here, and we get HCO3, so bicarbonate, and hydrogen. Okay, and then over here we have a transporter. Let's bring that here, transporter here, and basically this transporter allows sodium to enter at the expense of hydrogen. So hydrogen leaves, sodium comes in. On the other side, the basolateral side, the side next to the blood, we have a co-transporter. And this co-transporter takes sodium and bicarbonate. Into the blood. So what effect does this have on pH? Well, it, bringing in bicarbonate into the blood, which is making it more basic, right? And this keeps happening over and over and over. So we end up reabsorbing a ton of bicarbonate. So basically, at the PCT, so bicarbonate and sodium are reabsorbed in the proximal convoluted tubule. The hydrogen, so hydrogen ion concentration gets fine-tuned in the distal convoluted tubule and collecting duct. So we're reabsorbing all of this bicarbonate, baking soda basically, and then when we get to the DCT and the collecting duct, then there are specialized cells there that are able to monitor and are sensitive to acidosis and alkalosis. And depending on what side you're on, if you've got too much bicarbonate or too many hydrogens, then it has special, these specific cells have special like transporters that either conserve hydrogens or get rid of hydrogens depending on what the pH is there. All right, so in the next video, we're going to talk specifically about what's happening with pH in the distal convoluted tubule and the collecting duct.